Good day everyone! In this video, we will discuss about asymptotes of rational functions. Let us define first what is an asymptote. Asymptote is a line or a curve that the graph of a function gets close to but does not touch. As for this video, we will discuss about vertical and horizontal asymptotes only. Vertical asymptote. The vertical line x equals a is a vertical asymptote of a function f if the graph of f either increases or decreases without bound as the x values approach a from the right or left. On the other hand, we also have the horizontal asymptote. The horizontal line y equals b is a horizontal asymptote of the function f if f of x gets closer to b as x increases or decreases without bound. The question is, how are we going to find the asymptotes? These are the steps in determining the vertical asymptotes. First, reduce the rational function to lowest terms by canceling out the common factor or factors in the numerator and denominator. Second, find the values a that will make the denominator of the reduced rational function equal to 0. And finally, the line x equals a is the vertical asymptote. On the other hand, to determine the horizontal asymptotes, we have the following steps. Let n be the degree of the numerator and m be the degree of the denominator. Remember that the degree is the highest exponent at the variable. If n is less than m, the horizontal asymptote is y equals 0. If n equals m, the horizontal asymptote is y equals a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. And finally, if n is greater than m, there is no horizontal asymptote. Let us have some examples. For the first one, find all asymptotes of the graph of the rational function below. F of x equals 1 over x minus 2. Since the rational function is in lowest term, to find the vertical asymptote, set the denominator equal to 0 and solve for the value of x. Thus, we will have x minus 2 equals 0 and finally x equals 2. Thus, the graph has the line x equals 2 as its vertical asymptote. For the horizontal asymptote, notice that the degree of the numerator is less than the degree of the denominator. The degree of the numerator is 0, and the degree of the denominator is 1. Since n is less than m, therefore it satisfies the first condition, that its horizontal asymptote is the line y equals 0. This is the graph of f of x equals 1 over x minus 2, and it shows its vertical asymptote to be x equals 2, and the horizontal asymptote y equals 0. It means that no matter how long the graph extends, it will never touch the lines x equals 2 and y equals 0. Let us have another example. Find all asymptotes of the graph of the rational function f of x equals 2x all over 3x plus 1. Once again, since the numerator and the denominator has no common factor, we just need to equate the denominator to 0 and solve for the value of x. for us to be able to determine the vertical asymptote. Thus, we will have 3x plus 1 equals 0. 3x equals negative 1 as we isolate the constant term to the right side of the equation and divide both sides by 3. Therefore, we will have x equals negative 1/3. Therefore, x equals negative 1/3 is our vertical asymptote. On the other hand, notice that the highest exponent of the variable of the numerator is 1. So therefore, n is equal to 1. And the highest exponent at the denominator is also equal to 1. Hence, we can say that n is equal to m. And this satisfies the second condition. Therefore, the horizontal asymptote is the line represented by A over B, wherein A is the leading coefficient of the numerator and B is the leading coefficient of the denominator. Going back to our given, the leading coefficient of the numerator is 2, and the leading coefficient of the denominator is 3. Therefore, our horizontal asymptote will be y equals 2 over 3. This is the graph of f of x equals 2x all over 3x plus 1. It shows that the vertical and horizontal asymptotes are x equals negative 1/3 and y equals 2/3 respectively. Another example, find all asymptotes of the graph of the rational function f of x equals x squared over x plus 1. To determine the vertical asymptote, let us again equate the denominator by 0. So we will have x plus 1 equals 0 and then solve for x. So we will have x equals negative 1. So therefore, x equals negative 1 is our vertical asymptote. Moreover, for the horizontal asymptote, notice that the degree of the numerator is 2. So we can say that n is equal to 2. And the degree of the denominator is 1. So we can say that m equals 1. For this case, notice that n is greater than m. So it satisfies the third condition. The third condition states that if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. Therefore, the given function has no horizontal asymptote. This is the graph of the function f of x equals x squared all over x plus 1. The graph shows the vertical asymptote is x equals negative 1, and there is no horizontal asymptote. For our last example, find all asymptotes of the graph of the rational function f of x equals x squared minus 4x plus 3 all over x squared minus 5x plus 4. Here, notice that we can still factor the numerator and the denominator. Therefore, we will have x minus 1, quantity x minus 3 for our numerator and x minus 1 times x minus 4 for our denominator. If this is the case, then there is a common factor. It means that the graph has a hole. Since x minus 1 is the common factor, the hole is at x equals 1. Moreover, for the vertical asymptote, equate the remaining factor of the denominator to 0. So we will have x minus 4 equals 0 and solve for the value of x. Therefore, we will have x equals 4. Therefore, the vertical asymptote of our rational function is the line x equals 4. Going back to the given, notice that the highest exponents of the numerator and the denominator are equal, and they are both equal to 2. Hence, the horizontal asymptote of our rational function is the line y equals a over b, wherein a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. The leading coefficient of the numerator is 1. And the leading coefficient of the denominator is also 1. Therefore, the horizontal asymptote is the line y equals 1. This is the graph of the rational function f of x equals x squared minus 4x plus 3 all over x squared minus 5x plus 4. Notice that it has a hole at x equals 1, and the vertical asymptote is x equals 4, while the horizontal asymptote is the line y equals 1. I hope that you have understood the lesson. For the next video, we will discuss about the zeros and intercepts of rational functions. Thank you for listening and see you on our next discussion.